everybody. Today, I've got some secret messages for you. Yes, we're talking in code. So that's what we're going to do today. We're going to start talking about the basics of cryptography, the study of code making and code breaking. Okay? So we're going to start out with one of the very first ones from way back. Your basic Caesar cipher. Yes, that does come from Caesar. So the basic Caesar cipher is, let's take our alphabet. A through Z, you see I have written down here. And above every letter, I've written a number, starting with A is 1. And I just went all the way down to Z, 26 letters in the alphabet. And then notice I've got 27 here. What's under 27? Right, nothing, because we do need the ability to have blank spaces. So we went ahead and put a 27 in there for blank space. Now sometimes we might shift this. We might start with A being 0 and going all the way down to Z being 27 itself. So be aware of what it's set up for when I give you the problems to work on, okay? So with the basic Caesar cipher here, we've just simply assigned every number a letter. So if we go down here, we look at 9. 9 is an I. 27 we decided was a blank, so blank. 12 is an L. What do you think it's going to say? This is Mr. Manning we're talking about here. I don't know, L. 15 is O. 22 is V. I bet you're getting there. 5 is E. What is it Mr. Manning loves? Well, there's a blank space to tell you. 13, yeah, you guessed it, start with the letter M. 1 is an A. 20 is T. And 8, H. I love math. So there's your basic Caesar cipher, where basically each letter goes with a number. You just give me the numbers. Super easy to crack that code, isn't it? I mean, that's not the toughest thing in the world. So let's get something a little bit tougher to crack. How about this one? This one we don't have any numbers. In this case, we now just have the letters all mixed up. And I've told you the key is 3. Yeah, the key is 3. Knowing 3 is important. Why? Well, anybody have any suggestions? Any guesses? Any code crackers out there yet? What's that trying to say? Well, this is called the rail fence. So here's what we're going to do. We're going to total up how many letters there actually are. So let's count that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've got 12 letters there. And I told you the key was 3. So 12, what we do in the rail fence is divide the total number of letters by the key. So 12 divided by 3 gives us an answer. What is 12 divided by 3? Yeah, you know that one. It's 4. So 4 is how often you put a fence post. Every fourth letter, put a fence post. So we're going to count through. 1, 2, 3, 4, fence post. 1, 2, 3, 4, fence post. 1, 2, 3, 4, and we're done. Okay, well that doesn't seem to have told us the answer though, Mr. Manning. Why did we draw fence posts in the rail fence technique? Well, here's what we're going to do. We're going to take the first letter from each group, then the second letter from each group, then the third letter, then the fourth letter, and so on until we've used up all the letters. So, we start with our first letter, it's I. Here, first letter is F. Here, the first letter is E. Now we go do the second letters. E is the second letter. L is the second letter. L is the second letter again. Now go on to the third letter. U, C, K, and finally the fourth letter. Y, now you know the code. XX. Why did I put XX? Well, notice what I wrote, I feel lucky, doesn't have 12 letters in it. It only had, 10 letters. So I'd have to choose a different key or do something a little differently. So I went ahead and put in space holders. Oftentimes people use the letter X as a space holder. And so I feel lucky, space is basically what that's saying. So there's your rail fence. You count up the number of numbers, divide that total by the key, to get how often you put in a rail fence or a fence post. Then you take the first letters, the second letters, the third letters, the fourth letters, and write them out, and you get your code. Okay, now, last one, linear shift. And it looks as though Mr. Manning forgot the T. Linear shift, like that. And in linear shift, we've got numbers again. We're back to numbers. Now, in linear shift, we've got to realize this. We're assigning numbers to letters again. But we're going to do it differently this time. So I'm erasing all the numbers. All the numbers be gone. And this time, we're going to assign them a little differently. And it's because that's the way we did it on the worksheet. We went ahead and started for this one, for linear shift. A is going to be 0. Then B is 1, C is 2, D is 3, and then we go on down the line from there. That's funny, 6 is G. They look similar, huh? 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. Now, if I wanted a space here, I suppose I would call that 26. Okay? So, how do we do the linear shift? Well, in linear shift, I've given you a key, but the key is a formula this time. And this time it says y equals 2x plus 1. Now, what's really going on is that key is what they use to figure out these numbers. They've shifted the numbers. No longer is A the 0, and no longer is Z the 20. Notice 53. That's the largest number we have in here, 53, and there's only 26 numbers in the alphabet. So something's got to be going on, and that's exactly it. We're using this formula to get these numbers from here. So how do we reverse that process? How do we undo y equals 2x plus 1 if you plugged a value in for x and got a y value? What would we use to undo that? Right, inverse functions. That's exactly it. We're going to use an inverse function. So we're going to take this equation here and we're going to rewrite it as its inverse. So remembering how we do an inverse, we switch the x value and the y value. So we're now going to have x equals 2y plus 1. So now we're going to solve to get y by itself so that we can see what the new equation is to go backwards, to undo this. So we're going to subtract 1 from both sides and get x minus 1 equals 2y. Divide out the 2. Remember here, that's going to cancel. Divide out the 2, and we get y equals x minus 1 divided by 2. So that's what we have to do to these numbers to figure out then what values we actually get. So let's go ahead and calculate some of those. So if we take 17 minus 1, we get 16 divided by 2 is 8. 8 is the letter I. I'm going to write that above here. I. 53. 53 minus 1 is 52. 52 divided by 2 is 26. Ooh, there's the space. There's the space. So we can go ahead and just leave that there. 1. 1 minus 1 is 0. 0 divided by 2 is 0. And 0 is the letter A. 0. And let's go ahead and keep our red letters here. A. So we keep going. 25 minus 1 is 24. Divided by 2 is 12. 53 again is 27. 15 minus 1 is 14. Divided by 2 is 7. 1 again is going to be 0. 31's happening twice. 31 minus 1 is 30. 30 divided by 2 is 15. 49 minus 1 is 48. 48 divided by 2 is 24. Let's go ahead and get those letters in there now. 12 is the letter M. 27 was the... 27 is a space also. Oh, no, that's a 26. That's why, Mr. Manning. How did we get that? 53 minus 1 is 52. 52 divided by 2 is 26. Good thing I'm not doing push-ups anymore these days, folks. Oh my goodness. Okay, I'll do some push-ups. Here we go. Push up, push up, push up, push up. Okay, so 26 is getting the space. 7 is H. 0 is A. 15 is the letter P. Twice, I bet you know where we're going with this. 24 is the Y. Now I'm going to go ahead and do it. I'm just going to go ahead and put in some exclamation points there because I am happy. So folks, hope this was helpful. We're going to move on with some more of these as the week goes by, but for now, just go ahead and play with these 3, and feel free to send your friends some coded messages too from home so that you can have some fun practicing. Right on, folks. Have a good one. We'll see you next time. Here go the lights.